Our minds cannot comprehend the vastness of the universe. This vastness makes the task of finding extraterrestrial civilizations extremely hard. The most common method is to search for electromagnetic transmissions. But what if, for whatever reason, ET decides to remain silent? Is there another method that we can use to try to find them? If we assume that human-like intelligent beings are out there and they have created human-like societies, it is only logical to think that such societies, like us, are dependent on energy sources. Based on our own experience, the more technologically advanced a society becomes, the greater its energy requirements. Are extraterrestrial societies out there that are so power-hungry that they need to harness energy from a black hole, for instance? Can we take advantage of such a need to find those societies, even if they don't want to be found? Hello, I'm Dr. Alejo, and today we will explore the Kardashev Scale, a scale proposed in 1964 by the Soviet astronomer Nikolai Kardashev as a way to classify hypothetical extraterrestrial civilizations in terms of their energy needs. I have to admit, this is one of my favorite topics in SETI, given that it provides so many ways to speculate about these potential societies. Let's dive in. I believe everybody struggles with saving energy. After all, we don't want to pay an incredible amount of money at the end of each month. But the number of electronic devices in our households just continues to grow. TVs, mobile phones, routers to connect us to the internet, air conditions, you get the idea. Our human society is extremely dependent on electricity. Energy usage and its effect on our planet is a topic I'm extremely passionate about, to the point that my PhD dissertation dealt with how to save energy consumption in different types of computer networks. According to the Statistical Review of World Energy report produced by the Energy Institute, which I will link in the description, the global power consumption in 2024 was 18.8 terawatts. To put this number in perspective, 1 terawatt can power 10 billion 100-watt bulbs at the same time. The majority of our energy is still produced using fossil fuels though, but the role of renewable energy has increased in recent years. Our need for power is not going to slow down. Energy consumption tends to increase by about 1 to 2% per year. For instance, ChatGPT consumes over 500,000 kilowatts of electricity each day, which is almost equal to the power usage of 180,000 US households. It has been estimated that the whole IT industry will consume between 9.7 and 15.3 gigawatts annually by 2027.
21 gigawatts of electricity. 21 gigawatts!
A traditional Google search uses the equivalent energy to turning on a 60 watts bulb for approximately 17 seconds. Research like my PhD dissertation continues to happen all over the world, with people trying to optimize the use of energy wherever possible. But regardless of these efforts, we as humanity will continue to require and need more and more power. Based on our own experience, it is only logical to think that extraterrestrial technologically advanced civilizations also require large amounts of energy as they progress in their technological journey. In his paper titled Transmission of Information by Extraterrestrial Civilizations, Kardashev classified hypothetical extraterrestrial societies in terms of their energy needs in a scale from 1 to 3. Kardashev estimated that a Type 1 civilization should be able to harness all energy sources available in their home planet. And to put a number, Kardashev used the radiation that reaches Earth from the sun. This energy is in the order of 40 terawatts. But I just mentioned that the global power consumption in 2024 was 18.8 terawatts. So are we a Type 1 civilization? No way, because we are not really harnessing all the energy sources available on our home planet. We are barely harnessing only a tiny fraction of the solar radiation that reaches the surface of our planet. In addition, using all the sources available would mean exploiting to the full extent all of our traditional fossil fuels, such as carbon, petroleum, coal, natural gas, as well as all the renewable energy we can get our hands on. In this context, the term renewable energy extends beyond the traditional and popular, or maybe unpopular depending on where you live and or your political views, wind and solar natural sources of energy. Non-traditional renewable energy sources encompass biomass energy, which is derived from plants and animal waste, ocean energy, which transforms the kinetic energy due to the movement of water into electricity, and geothermal energy, drawn from the Earth's internal heat, including that from volcanoes. My favorite non-traditional renewable energy source is tectonic energy, which derives power from the movement of tectonic plates, or in other words, the mechanism on Earth that causes earthquakes. To consider all these other sources of energy, in 1992, the Argentinian astronomer Guillermo A. Lemarchand redefined the energy consumption of a Type 1 civilization as one that generates 10 to the 16 power watts. So, based on this definition, humanity is still 4 orders of magnitude, or 10,000 times, away from becoming a Type 1 civilization. Of course, Carl Sagan had something to say about this. Sagan realized that having civilizations categorized with integer numbers, 1 to 3, was not the best way to model the evolution of civilizations. In his book, The Cosmic Connection, an Extraterrestrial Perspective, Sagan proposed a new classification schema, still based on Kardashev's types, but introducing a formula that allows the calculation of intermediate levels. Essentially, Sagan uses the power consumption of the civilization as input and produces as an output the number representing the type of that civilization. Sagan calculated the current humanity scale to be 0.7 and defined humans as being at a technological adolescence age with the ability to self-destruct, which sounds about right, if you ask me. Optimists like Michio Kaku have estimated that humans will reach Type 1 between 100 and 200 years in the future. Other researchers have estimated that humanity will reach this stage in the year 2347. This has been calculated based on an exponential growth model for calculating total energy production and consumption as a function of time. Once a civilization's energy requirements grow beyond the resources available to them in their home planet, they need to look elsewhere, but not too far away. They look at their home star. Kardashev suggested that Type 2 civilization would require, and therefore be able to produce energy in the order of a 1 followed by 26 zeros watts. To achieve that, that civilization must develop a technology capable of capturing the majority or the totality of the energy produced by their home star. To achieve this, they will need a megastructure around the parent star. This is different to what we discussed about using the star energy that reaches the home planet, given that the star radiates in all directions and not just in the planet's direction. Known as Dyson sphere, the concept of this potential megastructure was introduced by Freeman Dyson in his 1960 paper Search for Artificial Stellar Sources of Infrared Radiation. A Dyson sphere consists of orbiting satellites covered with solar panels around the star with the intention of capturing as much solar energy as possible. This energy can then wirelessly transmitted through space to the home planet or other parts of the solar system the Type 2 civilization inhabits. The feasibility of a single solid structure around a star has been put in doubt, as it would be difficult to construct and maintain. For this reason, variants to the Dyson spheres have been proposed. The Dyson swarm is one of the most popular. The Dyson swarm is composed of living habitats, satellites, energy collectors, and self-replicating machines which orbit around the star resembling a net. Energy is transferred wirelessly between each component and the home planet. This will of course require a precise synchronization between all the components, a really hard engineering challenge. Another variant of a Dyson sphere is a Dyson ring. A ring of solar power collectors is positioned around the home star on a Dyson ring. This is the simplest, cheapest, and most technologically achievable version of a Dyson sphere, and one that a potentially advanced civilization who could have used as their first step to collect energy from the parent star. With this type of energy, a Type 2 civilization would have colonized the entire home planetary system. This is similar to how humanity is portrayed in the awesome sci-fi TV series The Expanse, which I highly recommend. In the TV show, humanity has colonized Mars, the asteroid belt, has space stations and bases around Jupiter, Saturn, and their bigger moons. It is awesome. A Type 2 civilization is not going to stop there. They will need more. Once a Type 2 civilization has colonized the entirety of their home planetary system, they will want to embark in master interstellar travel, either because their energy needs required or because their hunger for colonization and exploration takes them there. Therefore, they will need to utilize the energy produced by all the stars, including black holes, neutron stars, and every conceivable celestial object in their home galaxy. The energy requirements are now estimated to be in the order of a 1 followed by 36 zeros watts. A Type 3 civilization has therefore mastered interstellar travel and has more than likely colonized many of the worlds orbiting the stars in their galaxy. A Type 3 civilization is hard to conceive. In a very speculative way, the beings that comprise such a civilization would be some sort of immortal self-replicating AI machines or von Neumann probes that don't have the constraint of time or the ability to get bored, given the immense distances that interstellar travel requires. We explored von Neumann probes in the Fermi Paradox episode, which I invite you to check out. Kardashev only considered 3 types of civilizations, but other researchers, astrophysicists, and even sci-fi writers have proposed the existence of Type 4 and Type 5 civilizations. For the human mind, the size of a galaxy is almost impossible to conceive. Our own Milky Way galaxy is estimated to have a diameter of 100,000 light years. This means that traveling at the speed of light, it will take 100,000 years to traverse. If this is not enough to make your head hurt, galaxies are grouped in so-called galaxy clusters. Galaxy clusters are the largest objects in the universe that are bound together by their own gravity. Galaxy clusters are made of 4 main components: stars and interstellar gas that make up about 5% of their total mass. 15% is hot plasma, which is gas where the electrons have been stripped from the atoms, and dark matter, a still unknown type of matter that holds everything together, which constitutes about 80% of the totality of mass in the galaxy cluster. Type 4 civilizations have been theorized to be able to harvest and control the energy of their own cluster of galaxies, and eventually its own universe. This implies that they have mastered intergalaxy travel, something that not even the crew of the original Star Trek ships were able or allowed to do. The energy need and generation of such civilization is in the order now of 10 to the 46 watts, or the power comparable to the luminosity of the observable universe. But if your head hasn't exploded just yet, Type 5 civilizations are so advanced that they have been able to escape their universe of origin and have adventured to explore the multiverse. They are potentially able to have mastered the laws of physics and have almost complete control over the fabric of space-time and reality. The energy usage of such civilizations would be in the order of 10 to the power of 56 watts to 10 to the power of 66 watts. Spoilers ahead, we can potentially see a member of such civilizations at the end of the first Men in Black movie in 1996. Marble Alien, as it is known, is an enormous extragalactic alien casually playing with marbles containing whole galaxies. The hypothesis of the multiverse is based on the idea that our universe is just one of many. Each of these universes potentially has their own set of physical laws and exists independently or is connected to others in some way. Various physical hypotheses such as eternal inflation, string theory, many-world interpretation of quantum mechanics support, at least mathematically, the idea of the existence of the multiverse. But there is a problem with the multiverse hypothesis. The falsifiability of the multiverse hypothesis is highly debatable. Falsifiability is the principle that a scientific hypothesis or theory must be constructed in a way that it can, in principle, be proven false through empirical observation or experimentation. In other words, If a hypothesis or theory cannot be tested or disproved, then such a theory is not considered a strong scientific hypothesis or theory. Carl Sagan talks about the falsifiability concept in his book, The Demon-Haunted World, in a way that only Sagan could explain. He says, imagine I tell you, a fire-breathing dragon lives in my garage. But this dragon is not only invisible, it is incorporeal, flooring, and spits heatless fire. So there is really no conceivable experiment that would count to prove or disprove its existence. The same happens with the multiverse hypothesis, as there is not really, at least for now, a conceivable experiment to prove its existence. For this reason, Type 5 civilizations are barely discussed. It is fun to imagine those beings anyways. But how does the Kardashev scale help the SETI field? The answer to this question is infrared excess. For Type 2 civilizations, or those that have successfully enclosed their home stars employing Dyson spheres or other types of astro-engineering constructions, the re-emission of infrared radiation back to space would be a sign of their existence. The idea is essentially to explore catalogs of celestial objects in the infrared, to identify potential sources that are emitting an excess of infrared radiation of unclear nature. One of those studies was led by Kardashev itself in the year 2000. In this study, researchers explored the Infrared Astronomical Satellite, or IRAS, database to search for evidence of Dyson spheres and other potential alien constructions. The IRAS database includes 350,000 sources. Unfortunately, no Dyson spheres were found as part of this study. In a more recent study in 2024, astronomers searched for excess infrared radiation at 5 million stars located within less than 1,000 light years from Earth. They used data collected by the NASA Wide Field Infrared Survey Explorer, or WISE, telescope and NASA's GAIA observatory. WISE, launched in 2009, is repeatedly mapping the entire sky in infrared light. GAIA, which was launched in December 2013, has made more than 3 trillion observations of 2 billion stars and other objects throughout our Milky Way galaxy and beyond, mapping their motions, luminosity, temperature, and composition. At the end of this study, researchers identified 7 sources that are indeed presenting excess infrared, but more data and analysis is required before the discovery of Dyson spheres can be announced. The same infrared excess concept applies to Type 3 civilizations. In this case, astronomers direct their attention to entire galaxies instead of focusing on individual stars. Unfortunately, nothing has been found so far. There you go. The Kardashev scale has been conceived based on our own experience with technology here on Earth. Is every single extraterrestrial civilization going to go through a technological progress like the one we as humans are going through? It could also be that some civilizations didn't develop enough technology, so they are detectable, or they could have destroyed themselves before reaching certain technological stage. Let me know in the comments what incredible milestones you think one of these civilizations could have achieved. I'm also interested in knowing your opinion about the usefulness of the Kardashev scale in the quest of finding aliens. In my opinion, I think it is one of the best approaches we have, given our understanding of technological development and our ever-increasing needs for more energy. If you enjoyed this content, please consider liking this video and subscribing to the channel. Also, remember to press the bell icon so you get notified when I upload new videos. I also invite you to check my video about the Drake equation, which is highly relevant to the topic we discussed today. And check out my book, Story of More Than 5,000 Worlds, where we explore the Kardashev scale at a deeper level. That's it for now. And remember, the truth is out there.